All right, let's talk about the other rule of probability. This is the addition rule. And the addition rule is denoted by the word or and the union symbol. So you can think of, or this symbol, which looks like a U, stands for union, where by contrast, when we're talking about intersections and the word and, we would use an upside down U to mean intersection. Okay. So let me show you how the addition rule is a little different. So here you are going to be calculating the probability of two events happening such that E or F occurs. And remember that using E or F is equivalent to using E union F. And here's what a Venn diagram looks like. So if this green oval here represents event A, and this blue oval here represents event C, then the union of A and C is everything in both, just like that. Now, contrast the addition rule with the multiplication rule using the analogy that we used earlier. A statistics student goes to a farmer's market wanting a plum or an apricot. In this case, the statistics student would be happy to walk away with one fruit, either a plum or an apricot or a pluot, which is the intersection of a plum and an apricot. Okay. So if a student wanted a plum or an apricot, they would be happy with walking out of there with a plum, an apricot, or the intersection of the two, which would be a pluot. Uh, just like um, just like the multiplication rule, there are two variants uh, for the addition rule as well. Instead of being based on whether two events are dependent or independent, they're based on whether they're disjoint or not disjoint. Okay. And if you remember, not disjoint means they overlap. Disjoint means they do not overlap. And what you'll notice is that between these two equations, they're nearly identical, except the non-disjoint one has this subtract the probability of the intersection. So subtract the probability of the intersection of those two events. And you can see here that that term appears to be missing here. Why is it missing? It's missing because if they're disjoint, there's no intersection. So what's the probability then? If there's no intersection, the probability of the intersection is 0. And so we typically don't even put subtract 0 because that doesn't change anything. So that's why this term up here is missing down here, is because the events are disjoint. There's no intersection. So there's nothing to add or subtract in. So you could just, always use this equation. And when you go to look at the intersection will be 0, and that'll just cancel out right away. Okay. So something to think about. So again, I'm just kind of restating what I just talked about here on this bottom part. Here you've got two events. Here you've got two events that are disjoint. So this is the addition rule that you use. Here are two events that are non-disjoint. This is the addition rule that you use with that extra term there at the end. Here you can see that the intersection is 0. Okay, there's nothing in between them. And here the intersection is not 0, it's some number because they overlap. All right, so let's look at our first example here. We're looking at a sample space of two six-sided dice. So our sample space is going to be two six-sided dice. And what you see here is every combination of two six-sided dice. You can see I've got snake eyes here and two sixes up here. So an outcome of 2 down in the bottom, an outcome of 12 there at the top. And we're going to define event E to be the result of a 7 and event F to be where the white die is equal to the black die. And what we want to do is calculate the probability of E or F. The probability of rolling a 7 or where the white die is equal to the black die. So the first thing let's draw in here is let's draw in the fact that our sample space is all possible outcomes. Okay, so let's find where event E is in all this. So it's where the sum of the two dice is going to be a 7. So it's going to be all of these combinations here. 4 and 3, 5 and 2, 6 and 1. Okay, that is event E. How about event F? So that's where the white die equals the black die. Well, so that means they're both going to have the same number. So it's going to be 1, 1, 2, 2, 3, 3, 4, 4, 5, 5, and 6, 6. That is event F. All right, so what you can see here is that event E and event F have nothing in their intersection. All right. I mean, just because of the way I drew it, you say, oh, well, they do overlap there. I'm talking about they overlap on an outcome. There's no combination of the two dice that's in both E and F. You can't get a 7 with two dice being the same number, right? Either you get a 6, which is two threes, or you get an 8, which is two fours. You can't have two dice that add up to 7. Okay. So what you've got here is you've got where E and F are disjoint. They are mutually exclusive. Okay. Now, because of this, we could just dive right in and say, well, the version of the addition rule we want to use is this one. Okay, great. If you know that, go for it. But let me go ahead and put in here this term, which was in the other version. Now, if we had to account for this, right, if we wrote this down right off the bat, and we needed to think about it, and we look here in our Venn diagram and we go, oh, look, there's nothing in their intersection. The intersection is 0. That's going to take that part of it and get rid of it. And now we're back to what we should use. Okay. So if at a starting point, you just always start from this non-disjoint term or expression or equation, which is longer, you're going to be okay as long as you can identify the intersection and identify whether it's going to be 0 or not. Okay. All right. So now we just have to consider the probability of each single event. So what's the order of event E? How many do we have? Well, we've got 1, 2, 3, 4, 5, 6. Get rid of those colors. All right, we've got 6. So 6 is in event E with a sample space of 6 times 6, which is 36. And then event F, we've got 1, 2, 3, 4, 5, 6. That's going to be 6 out of 36. Um, so we can do this in several ways, but I guess maybe the easiest is to notice that at least we've got common denominators, so we can add these two fractions. So that's going to give us 12 out of 36. And we can just use our calculator and do 12 divided by 36. And that comes out to 1/3, which is 0.3333 repeating, or the probability of E or F is 33.3%. Okay, so the probability of getting a 7 or doubles is 1/3. All right. So let's leave it there before we move on to the next one. So let me know if you have any questions.